Okay, in this section, we're talking about quadratics that are written in standard form. And I know with our guided notes, we've kind of gone in a crazy order, but overall, I just kind of want to give the next three sections, they talk about the different forms of the quadratic. So our quadratic function, remember, is any function that has a degree of 2, and they can be written in these three different forms that I've written here at the top. Vertex form is the one that we just dealt with a little bit. It looks a lot like the absolute value. We like vertex form because when we're identifying parts of the function or key features, all we have to do is identify the vertex taken right from this opposite of h and this k value, and that gives us the vertex. Once we know the vertex, we know the axis of symmetry because it goes right through the x value of the vertex. We can figure out like the range. So we really like a vertex form. The a value is also easy to deal with, right? Because if it's a positive a, then it was opening up and it was a smiling graph. If it was a negative a, it was opening down. So those are all things we want to make sure that we understand with the vertex form, that we're really comfortable with that. When we write a quadratic in standard form, again, it looks something like this. So notice it still has that degree of 2, that highest exponent of 2. We practiced writing these in standard form at the beginning of the year. Notice the a value is also there. This one acts just like any other a value. You'll notice on all three forms, I didn't even talk about this third one yet, but that a value is still telling you whether it opens up or down. So we like that the a value is consistent between all three forms, that leading coefficient. Then you'll notice in standard form we have an a value, we also have a b value and a c value, that constant value there at the end, and then we have the b value on the inside with the x. They use different variables to represent the different coefficients in this one. They use b and c because these aren't just the h and k like the last one. We can't identify the vertex in the same way. This one's been shifted left or right if there's a b value, so we have to consider that change in the vertex. Notice here, if you look at the intercept form, this one's the factored form. We liked this one also. We practiced writing it in factored form so that we could solve it, right? X would be p, x would be q. Those are like the solutions or the x-intercepts. So we like this form. We'll talk about that one in the next section. But essentially today we're going to focus on, or this section, we're going to focus on the standard form. Now, if you can find the vertex, we can find all those other key features. So the goal here will be to make sure that it's written in standard form, and then to find the vertex of this. Again, we can't just do hk, we don't know what h is, but to find that h value or the x value of the vertex, we really just take this little formula and we do the opposite of b. So again, that b value comes from the coefficient of the middle term, and we divide it by 2 times the a value. That gives us the x value of the vertex. And then to always, if we want to find a y value, we just put the x back into the original equation. So we're going to use that a lot as we move forward today. So I'm going to move through these notes rather quickly. A lot of it is just very wordy, so just kind of read through. If you forget, you can do parts of it. But the goal is really to be able to look at a quadratic function and identify the vertex, but also to understand, is it opening up or down? Does it have a max or a min? How can we take one step back and understand it without having to just plot it on a graph? So for the bell ringer, it says multiply to write each equation in standard form. So I just want us to remember that we know how to put these in standard form. We kind of started our quadratics off with this, where we could take something in factored form and we could FOIL it to write it into standard form. So in this case, we would get 2x squared minus 1x minus 2x plus 1 when we multiply all those pieces. Those two middle terms are like terms, so negative 1x minus 2x is negative 3x. And this right here would be standard form. Then we can identify those a, b, and c. So again, a comes from the x squared term, that would be 2. The b is on the x term, so that's negative 3. And the c is the constant, so that's the 1. Oops, I underlined the other one. Same thing with this next one. Remember, if it's x minus 3 squared, then that means there's 2 of these, so we put them side by side. And then we could FOIL, so we get x squared. We get x times negative 3 is negative 3x. Negative 3 times x again, negative 3x, and negative 3 times negative 3 is a positive 9. So when this one's in standard form, and we combine that middle term, we get x squared minus 6x plus 9. Again, the a comes from the value in front of the x squared. Now, if there's not one written, remember it's always a 1. So this a value is 1. B is going to be negative 6. and C would be the 9. Okay. On this last one, it looks like there's just a distribution, so we just have to multiply the x in. We get x squared, and then x times -4 is -4x. Notice on this one, when we define our a value, again, there's nothing written out front, so a is 1. The b value is -4, and the c value here is non-existent, meaning there's a 0 for our constant. Okay, so our learning target here is students will be able to, you're basically going to define the key features. That doesn't say features. From standard form. So we practiced with it from intercept form. This is from standard form. So again, I've given you the standard form right here to just remind you. And then remember the a value and b value and c value come from those coefficients or those numerical values. The easiest key feature actually to find is the y-intercept from the standard form. And that's because y-intercepts occur when x is 0. And if you think about, if I take y is equal to, let's say we have 2x squared plus 3x plus 1. If I put 0 in for x, because that's when, so when x is 0, then we have y-intercepts. So if I put a 0 in everywhere I see an x, right? Every time I do that, when I put a 0 in for x, this becomes 0. This becomes 0 because we multiply by 0, we get 0. So it's always actually just this c value here on the end. So if you can figure out what the c value is, then that y-intercept, and again, y-intercepts occur when x is 0, is always just that c value on the end. And then the concavity, I kind of talked about that. So that's the second feature that's really easy to identify. When the a value out front, if it's positive, then the graph is opening up, right? It's smiling. If it's negative out front, then the graph is opening down, like it's frowning. So if we come down here, we can practice just with a couple of those features. It says use the y-intercept and the observed value of a to match each equation with the graph. So for example, if I'm looking at this first one, and I want to match it with a graph, I look right here and I know that this graph is going to be one that's opening down. So if you're looking at the options down here, it can't be graph 1, that's opening up. Graph 2 is opening up, and so is graph 6. So A has to be 3, 4, or 5. The other part that we just talked about is the y-intercept is over here in the function. So we know it's opening down, and then it has a y-intercept of -1. If we look at graph 3, notice its y-intercept over here. It's crossing at positive, it looks like 5. So if that one's crossing at positive 5, then that can't be A, because A is crossing at -1. So it would be down here at graph 5. Notice this is opening down, which is what we want, and it's crossing at -1. So we would match graph 5 with A. And we could then go to, so we finished A. If I go to B, B is opening down, right? Now it's been shrunk a little bit, but in this case it's not really going to matter. We just know that it's opening down and that it should be crossing at a positive 5. Well, that looks like the one that we just looked at over here at graph 3. So if you want to pause the video and try a couple of these, you can do that. But essentially that's what you're looking for. Opening up on C, down 5, or crossing at -5, I apologize, the y-axis. So that would be this one right here. Graph 1. Graph 2, we're looking at one that's opening up and crossing at a positive 4, so it looks like F has that positive 4 on the end there. And we can just kind of do that same thing on each of these. Graph 4 would be E, because look, it's crossing at that positive 1 and it's opening down. E is a positive 1 and has a negative in the front, which means that graph 6 is going to be D. And again, you can confirm that because it's crossing at -7. So those y-intercepts can help us, and it's probably the easiest thing to just pull directly from the graph, okay? For all other key features, we're going to use that little formula that I talked about at the beginning. So your axis of symmetry, remember, is the x value of your vertex. So you can go ahead and find that first, or you can jump to the vertex and follow the steps. They're going to be the same to find the x value. So the axis of symmetry, again, we're going to use this formula, the -b over 2a. So we need to practice identifying our A, B, and C. So again, remember they come from these values right here. Now in my formula, I only use the A and the B. Remember that C value helps us with the y-intercept. So when I find my axis of symmetry, I know it's always a line, x equals. If A is 3 and B, and I'm going to write it right here so that we just identify those. If B is -6 and I use that formula, that's like having negative B over 2 times the A value, which the A value was 3. If I simplify that, I end up with a +6 over a +6, which is a +1 when we divide that. So in this case, x is equal to 1 would be the axis of symmetry. Now, because x equals 1 is the axis of symmetry, that is the x value of the vertex, right? And you can identify, again, if you look down here, step 0, identify A and B values. We did that. Step 1, find the x value of the vertex. We actually just did that. We used that formula to find the x value of the vertex. So if you found the axis of symmetry, then the hard part of your vertex is done. Again, if we want to find the y value of the vertex, then we take the x we did find and we plug it in for x into the original equation. So when x is 1, y would be equal to 3. And again, I'm just going to put 1 into the equation. And we substitute it in. So 3 times 1. 1 squared is just 1, right? 1 times 3 is 3. Minus 6 plus 1. So 3 minus 6 is -3, plus 1 would be a -2. So -2 becomes that y value of the vertex. Okay, again, just follow those steps as recorded there. Once you have the vertex, you can find all the other pieces. So again, if we look at this function, this has a +3 in the front, meaning it's opening up. So this graph has, that vertex represents the minimum on the graph. And the minimum value it ever reaches, right, is this y value of -2. That's the lowest your graph ever goes. So we could say this one has a minimum value, and the minimum is always the y value of the vertex. Okay, so if you forget that, that's written. The domain, remember, is always -infinity to infinity, or all real numbers. And then the range, again, we just need to know if it's opening up or down, and it comes and meets that vertex wherever it is. So again, if this one's opening up, then our range starts right here at that vertex. So we would say -2, and it would go up forever, so up to infinity. Or those of you that like to write y is greater than or equal to -2, you can do that too. Okay. Now, if it was opening down, notice the range, if it's opening down, starts from -infinity and then would go up to that y value. So it's kind of recorded there as well if you need to go back and read those. So let's try this on a few of them. The first one, we're given an equation g of x, and we're just going to find these specific key features. So again, if I want to find the axis of symmetry, I need to know my a value, which in this case is 2, just the number out front, and my b value is equal to 4. Now again, why is the c value helpful? Well, remember the c value tells me my y-intercept, so I could actually come all the way over here to the right, and I know that my y-intercept is already 0, -1. Okay, and then my axis of symmetry, remember, comes from that formula, -b over 2a. So I'm going to take this and say, well, x is equal to, my b value is 4, so I'm going to have -4 over 2 times the a value, which is 2. So -4 over 4. And in this case, it looks like we're going to have x equal to -1 for our axis of symmetry. Now, again, you did the hard work for your vertex there, for your x value. Those are always the same. Then we just need to find out, okay, well, what is y, or g of x, when x is -1? So we take our original function, and everywhere there was an x, we're going to put in that -1 that we just found. And then we simplify. So if you square a negative, it becomes just a +1. 2 times 1 is 2. 4 times -1 is just -4 minus 1. So in this case, when we simplify that, we get -3. So we put that up here in our vertex, and we know that that's going to be the vertex there. Again, the domain, -infinity to infinity. All real numbers there. And then the range, remember we look to see if it's opening up or down. So we look out front, it looks like it's a +2. So this is going to be opening up. So our range is going to go up to infinity, and it comes from the y value of the vertex. So we just found that that was -3. And there's our key features. Let's try it again. So this bottom one, again, if you look out front of the x squared, there's just a negative sitting there. Remember, it's like there's a 1 there, so a would be equal to -1 in this case. B would be equal to -8. And then again, we don't need the c value for this part, but that c value gives us the y-intercept. So this time the y-intercept is right down here. It's asking for the y-intercept. So I'm going to put it down here. And then again, I can use that formula to calculate the axis of symmetry. So x equals -b, or in other words, opposite, right? -8 over 2 times a. So in this case, it looks like I have a +8 on top over 2 times -1 is -2. So this is going to come out being -4. Okay. Then to identify the vertex, again, you just found the x value of your vertex. So now you're going to take your original equation, and everywhere there is a parenthesis or an x, we're going to put in the -4 that we just found. Okay. Now remember, when you square something, so -4 squared is 16. So that negative is still out front there, and then if we square the -4, we get 16. We have -8 times -4, which is +32, and then -17. So we're just going to keep simplifying that. -16 plus 32 is a +16, minus 17 is -1. Now you can use your calculator to simplify that part. You can actually just pull the whole thing in at once from here, and then it will give you -1. All right, so we've got our vertex. Our domain, again, is -infinity to infinity. And this time, again, the range, if we look out front, we now have a negative a value, or a negative coefficient in the lead. So this time it's opening down. So your range is coming from -infinity. And then it will stop at the y value of the vertex. So in this case is that -1. Okay. Then at the bottom it says, does this have a max or a min? Now notice we decided that it opened down. So this is going to have a max up here. And the maximum, again, is just the top of the range, or in other words, the y value of the vertex. So this has a max of -1. Okay. And again, if you feel like you're understanding it, you could stop there. I'll do this last example. Go through it kind of quickly. So again, our a value on this one is 3. Our b value, notice there is no x term. There's no middle term. It's missing. So the b value must be equal to 0. And in this case, the c value is 11. So again, that helps me with my y-intercept. I know that the y-intercept is at 11. Oh, I apologize. It's -11. The vertex then, we find after we do this axis of symmetry. So we know that x is equal to -b, or in other words, 0 over 2a. Well, 0 divided by anything is just 0. So our axis of symmetry is that x equals 0. That is the x value of our vertex. And if we put 0 into the original equation to find the y value of our vertex, notice that we get 0 squared, which is 0 times 3. That just is 0, so it looks like it's -11. So our vertex is at -11. Domain, all real numbers. The range, again, if you look out front, that's a +3, the a value. So we know that it's opening up. So this is going to have that minimum, and the range is going to go up to infinity. It's going to come from the y value of our vertex. Now again, going off that little picture, we know that we had a minimum, and it's a minimum of -11, and then it gets bigger from there. So again, practice using that formula, the -b over 2a. Go back to those steps if you ever need to kind of walk yourself back through the steps. The more you do this, the more comfortable you are with that formula. Careful with your negatives. That's the biggest thing, is watching for those negatives.